Good morning, students. In today's class, we are going to see some more problems in projectile motion. Next one. The trajectory of a projectile in a vertical plane is y is equal to ax minus bx square, where a and b are constants and x and y are respectively horizontal and vertical distances of the projectile from the point of projection. The maximum height attained by the particle and the angle of projection from the horizontal arc. Okay, they had given an equation for the projectile. We have to find the angle of projection and horizontal angle of projection from the horizontal and maximum height attained by that. So first we write the equation y is equal to x minus bx square. Then we have to find maximum height capital H and angle of projection theta. Comparing with standard equation, that is y is equal to tan theta into x minus g by 2 q square cos square theta into x square, we get tan theta as a. That is theta is equal to tan inverse b. So we know that at maximum height dy by dx is equal to 0. That is slope becomes 0. Then differentiating the given equation with respect to x, we get dy by dx as a minus 2bx, that is equal to 0, where x becomes a by 2b. Okay, therefore from the starting equation, that is y is equal to ax minus bx square, instead of y we have to keep h is equal to, condition is x is equal to a by 2b, that is a into, instead of x, a by 2b minus b into, instead of x, a by 2b whole square. That is, the second term becomes a square by 4b. That is, first term becomes a square by 2b minus a square by 4b. That is, we get a square by 4b. Okay, this is the value of h. Next problem. A projectile is given initial velocity of I cap plus 2j cap. The Cartesian equation of its path is, and they had asked to take the g value as 10 meter per second square. Okay, first we write the initial velocity. U bar is equal to I plus 2g. G is given as 10 meter per second. Comparing with U bar is equal to bxi plus byj, we get bx is equal to 1, by is equal to 2. Then tan theta can be written as by dx, that is equal to 2. The meaning is 2 is opposite side by adjacent side, that is 2 by 1. Then the opposite side is 2, adjacent side is 1. Then we get hypotenuse as 2 square plus 1 square, that is root 5. Okay, hypotenuse as root. Then cos theta becomes adjacent side divided by hypotenuse. Adjacent side is 1 divided by root 1 by 2. Then from the equation, we can write u square as 1 square plus 2 square, that is 4. That is 1 plus 4 equal to 5. U square as 5. We get u square as 5. Now, we go to standard equation. Y is equal to tan theta into x minus g by 2 u square cos square theta into x square. Y is equal to, instead of tan theta, we have to substitute tan theta as 2. 2 into x minus, they are asked to take the g value as 10 divided by 2 into, what is u square? We get 5. 5 into cos square. Cos square theta means we get 1 by root 5 whole square, that is 1 by 5. 2 into 5 into 1 by 5 into x square. These 5 gets cancelled and 2 5 becomes 2 into 5 becomes 10. That is, we get 5. That is the whole equation. Y is equal to 2x. For the second term, we get 5x. Then the equation becomes y is equal to 2x minus 5x square. Next problem. The range arc of a projectile is same when its maximum heights are h1 and h2. What is the relation between r, h1 and h2? That is, for two different angles, we get same range. For those two different angles, heights are given as h1 and h2. We have to write the relation between these three quantities, that is R, H1 and H. First we write the equation. R is given as R1 is equal to R2. We just place the same range as R. Then writing for R1 U square by G sin 2 theta 1. If it is theta 1, the angle of projection with horizontal is theta. Then we write U square by G into, instead of sin 2 theta, 2 sin theta 1 cos theta 1. So U square by G 2 sin theta 1. We write the relation between theta 1 and theta. Theta 1 is equal to pi by 2 minus theta. Then writing for theta 1 for cos theta, cos pi by 2 minus 2. That is U square by G 2 sin theta 1 sin theta. Similarly, writing for cos 2, we get U square by G sin 2 theta. U square by G 2 sin theta 1 cos pi by 2 minus theta 1. That is U square by G into 2 sin theta 2 sin theta. And also we write the formula for maximum height. H1 is written as U square by 2G sin square theta 1 and H8 is written as U square by 2G sin square theta 2. Then we take R square, that is R1 into R. That is, seeing those two, we can get 4 multiplication factor U square by G sin square theta 1 into U square by G sin square theta. Then, and in the case of H1 and H2, we have to get 2G in the denominator. Then, writing for the 2G in the denominator, we get the multiplication of factor with the factor 16. 16 into U square by 2G sin square theta 1 into U square by 2G sin square theta. It becomes 16 for the first one, U square by 2G sin square theta 1, we write H1. Similarly for the second one, H2. 16 H1 H2. Then R becomes 4 into root of H1 into H2. Okay, this is the relation between R, H1 and H2. Next problem. The stone is thrown at an angle theta to the horizontal, reaches a maximum height h capital H. Then the time of flight of stone will be. So, theta is given, maximum height is given. We have to write the expression for t. Okay, and first write the formula for h. Maximum height is given by U square by 2G into sin square. Then h is the value given to us. Therefore, we write for U sin theta. That is equal to root of 2Gh. We get U sin theta as 2Gh. Then we write the formula for t. This time of is given by 2U by G sin theta. There we get 2 by G into, instead of U sin theta, we substitute root of 2G. That is, we get 2 into root of 2H by G. This is the value of time of flight in terms of maximum height. Okay. Then next problem. The speed of a projectile at its maximum height is root 3 by 2 times its initial speed. If the range of the projectile is n times the maximum height attained by it, n is equal to. Yes, they had given at maximum height the speed is root 3 by 2 times its initial speed. If the range of the projectile is n times the maximum height, then we have to find the value of n. Okay, at maximum height, ph is equal to root 3 by 2. Then also they had given that r is equal to n. We have to. Next problem. The speed of a projectile at its maximum height is root 3 by 2 times its initial speed. If the range of the projectile is n times the maximum height attained by it, n is equal to, that is, they had given some relation between the maximum height as n times its range, that is, r is equal to nh. Also, the initial condition is at maximum height, its speed is root 3 by 2 times the initial speed. At maximum height, velocity is taken as Vh, that is equal to root 3 by 2 times the initial speed v. Then r is equal to n into 2. We have to find the value of v. At maximum height, Vh is equal to root 3 by 2 times the velocity. We have to square that one, that is Vh square is equal to 3 by 4 u square. At maximum height, we are going to have only horizontal component. Then it becomes Vh square becomes u square cos square theta, that is equal to 3 by 4 u square. Then we get cos theta is equal to root 3 by 2, that is theta is 30 degrees. We write the formula for h, maximum height. U square by 2g sin square 30 degrees, that is u square by 2g into sin 30 is half, that is we get 1 by 4 factor. Then writing for horizontal range, r is equal to u square by g sin 2 theta, that is here becomes 60 degrees, that is u square by g sin 60 is root 3 by 2. Then we substitute the value of u square by g from the expression of h, that is from the expression of h we get u square by g as gh. We substitute the value of u square by g as 8h in this equation, that is u square by g, we replace that one with 8h. Then the r becomes r is equal to 8h root 3 by 2. Then we get 4 root 3h, where it shows n value as 4 root 3. This is how we can get the value of, the value of n is 4 root